Hello, my name is Gabriel Diaz, and I am the director of the Perform Laboratories at RIT's Center for Imaging Science. Perform stands for Perception for Movement, and that's because I'm interested in studying how humans use vision to guide action in both natural contexts For example, here I've used an eye tracker to study someone's visual behavior and how it guides eye movements during the performance of a cognitive task like counting or sorting. I've also studied visually guided actions in virtual contexts. Virtual environments are great because they balance the control of the laboratory task environment with an ability to generalize to real-world behavior outside of the laboratory. They also enable controlled manipulation of the visual task environment, allowing hypothesis tests that would be impossible through more conventional means. Whereas sensory and neurosciences tend to hyper-control their tasks to eliminate confounds, I have found that many of the principles governing visually guided actions, like catching a ball, are only apparent because of the freedom that this methodology affords, and not in spite of it. My efforts to use technology to ask novel questions about human visual and motor control have pushed against the limits of imaging and sensing technology and motivated applied work aimed at improving technologies like eye tracking. For example, a common critical step in the eye tracking pipeline involves estimating the location of the pupil in near-eye infrared imagery. In 2019, our novel machine learning method for detecting the pupil in near-eye infrared imagery won first place in the Facebook OpenEDS challenge. Since then, we have been hard at work developing new methodologies for sensing behavior using the mobile eye tracker. Here you see that the dynamics of gaze and the movement of the eyelids have been transferred from the original eye tracking video to that of an avatar that differs in appearance from the original person wearing the eye tracker. These techniques allow us to generate large data sets of synthetic gaze sequences that can be used to train machine learning networks for gaze estimation, no matter who you are or what you look like. Thank you for listening, and I hope that you enjoy the Frameless XR Symposium.